If you're building autonomous agents right now, you're facing a massive choice paralysis. There are dozens of agent development kits, or ADKs. Every major AI vendor has shipped an official SDK, and the open-source ecosystem is exploding with alternatives. But here's the problem. There is no empirical way to choose between them. Developer surveys tell you what people like, but not how the frameworks actually perform. And manual evaluation. That's an O(n times M nightmare that introduces bias and doesn't scale. A team from Microsoft and the Ohio State University solved this with a radical idea. They didn't evaluate the frameworks with humans. They replaced the human developer entirely with an LLM. The result is a paper and a pipeline called ADK Arena. They evaluated 51 popular Python ADK frameworks across 4 major benchmarks, and the findings reveal exactly how API design impacts LLM usability, which models make the best developers, and why your framework choice might be the bottleneck you didn't see coming. Let's dive into the methodology, the data, and what this means for the future of agent engineering. The core contribution here is a methodology called LLM-as-a-Developer. You've probably heard of LLM-as-a-Judge, where an LLM evaluates outputs. This flips the script. Instead of evaluating the result, we use an LLM to perform the work of the developer. The LLM-as-a-Developer agent is given a framework's GitHub repository and its documentation. It has to learn the API, write an agent that solves a task, and iterate until it works. This mirrors the exact explore, write, test, fix cycle a human goes through when adopting a new SDK. By holding the developer constant and varying only the framework, 2 signals emerge. First, the generation effort, tokens consumed, turns needed, failure rate, becomes a quantitative proxy for API complexity and usability. Second, the execution results measure the framework's actual effectiveness. They implemented this in ADK Arena, a fully automated pipeline. This isn't a hacky script, it's a rigorous evaluation system. Every framework gets its own isolated Docker environment. The LLM developer operates inside these containers with access to curated documentation and the raw source code. Crucially, the pipeline includes a 3-level validation system that catches errors before they waste compute. This is where the technical depth really pays off. Step 1 is static analysis. The validator runs compile checks, verifies imports, and scans the ASD for over 40 anti-patterns. It catches things like hard-coded URLs, SDK mismatches, missing timeouts, and even dummy references, where an LLM imports the framework but implements the logic via raw HTTP calls to bypass the API. If the code fails here, the LLM gets a structured diagnostic hint and repairs it. Step 2 is a real LLM smoke test. The generated agent is executed against a transparent token proxy. This verifies that the agent can successfully route requests, handle response formats, and consume tokens. It catches runtime incompatibilities and authentication errors that static analysis misses. Step 3 is the real benchmark task. The agent runs a smoke test from the target benchmark's official task set. For example, on SWE-bench, it runs a focused bug fix. On MCP-Atlas, it forces tool discovery and usage. This ensures the agent can survive a complete execution cycle without crashing. Once the agent passes all 3 levels, it's ready for full evaluation. The team evaluated 51 frameworks across 4 benchmarks: SWE-bench for software engineering, Tau2bench for conversational tool use, MCP-Atlas for multi-tool orchestration, and TerminalBench for terminal interaction. They ran 2 agents per framework benchmark pair, one generated by GPT-5.4 and one by Opus 4.6, all executing on GPT-5.4 Nano. The generation results are striking. Of 408 generated agents, 57% passed all validation levels. This proves that fully automated agent generation is viable for over half the ecosystem. But the cost to get there varies wildly. Per agent generation cost ranges from 60 cents to $3.40. That's a 5.6x spread. This cost is a direct proxy for API complexity. Frameworks like LangGraph and OpenAI Agents are among the cheapest to target, exposing clean, learnable APIs. But low cost doesn't always mean success. LangGraph is very cheap to generate, but it produces few passing agents because the API is so hard to learn that the LLM gives up early. Conversely, expensive frameworks like MCP-Agent and Atomic Agents cost more but still produce valid agents. So generation cost signals complexity, but it's not a perfect predictor of success. Now let's look at execution performance. Once the agents are generated, how well do they solve tasks? There is no single framework that dominates. The best single benchmark ADK agents resolve up to 80% of tasks, but the median framework resolves only 32%. Performance is highly uneven. The benchmark type matters a lot. Tau2bench is the most tractable, with a median resolution of 64% among running agents. This makes sense, it's conversational and forgiving. SWE-bench and TerminalBench are much harder, with medians of 18% and 14% respectively. These tasks demand long horizon, iterative editing where a single early misstep cascades into failure. Here's a finding that might surprise you. The model that writes the agent matters far more than the model that runs it. Both variants execute on the same GPT-5.4 Nano backbone, But agents authored by Opus 4.6 resolve roughly twice as many tasks as those authored by GPT 5.4. Opus-authored agents resolve 41% of tasks on average versus 22% for GPT. The difference is in the code quality. GPT frequently emits minimal agents that issue a single model call and return. Opus is much more likely to wire up the framework's full loop, register tools correctly, and iterate over multiple turns. Passing validation ensures syntactic correctness, but it doesn't guarantee task-solving capability. The developer model is decisive. We also compared these ADK-generated agents against frontier coding agents like Claude Code, GitHub Copilot, and OpenHands. The frontier agents are strong, but the top ADK agents are competitive. On specific benchmarks, well-chosen ADK agents can beat general-purpose frontier agents at a fraction of the cost. For example, on MCP-Atlas, the Agno framework resolves 68% of tasks using only 38K input tokens per task, beating Copilot's 58% resolution, which requires 327K tokens. That's roughly 9 times fewer tokens. However, this is a top-of-distribution effect. The median framework falls well short, so while a well-chosen framework can match hand-built agents, framework choice alone does not guarantee strong performance. The paper also includes a stress test by ablating the information sources available to the LLM-developer. This tests how robust generation is when you remove documentation or source code. The results challenge some assumptions about documentation. You might think more info is always better, but the data shows genuine framework usage stays within a narrow 28% to 40% band across all conditions. Surprisingly, source only yields the highest rate of genuine framework usage at 40%. When the LLM reads the raw source code, it makes native API calls more often than when it reads curated documentation. Docs only is the lowest at 28%. The researchers found that documentation's worked examples can actually anchor the developer. The LLM tends to copy or lightly edit those snippets, which often results in a thin wrapper agent that doesn't exercise the framework's native API. Stripped of examples to imitate, the LLM falls back on parametric knowledge from pre-training, which can lead to better native usage. Even with no reference material at all, 33% of agents still use the framework natively. This relies on the LLM's parametric knowledge of popular frameworks. The survivors skew toward popular frameworks like LangChain and CrewAI, because their APIs are heavily represented in the pre-training corpus. Niche frameworks collapse once all reference material is removed. Finally, the paper provides a deep dive into the ecosystem structure. They analyzed inter-framework dependencies and downstream adoption. The dependency graph shows a fragile supply chain. LangChain is the dominant hub with an in degree of 14, and Llama Index is the second hub. But here's the risk. 74% of inter-framework dependencies are undeclared code-only imports. Users who install the package will encounter import errors at runtime when specific code paths trigger these hidden dependencies. Adoption follows a steep power law. The top 5 frameworks account for over 93% of all ADK downloads. LangChain alone receives 233 million downloads per month. Stars and downloads diverge sharply. For example, MetaGPT has high star counts but low downloads, suggesting research interest without production adoption, while the Anthropic SDK has few stars but massive downloads as invisible infrastructure. So what are the takeaways for you as a developer or researcher? First, API design has a measurable impact on LLM usability. Generation cost is a viable proxy for API complexity, and clean APIs like LangGraph and OpenAI Agents are easier for LLMs to target. Second, the quality of the developer model is critical. If you're automating agent generation, using a stronger model like Opus can double your resolution rate compared to GPT, even on the same execution backbone. Third, documentation isn't a silver bullet. For LLM developers, raw source code can sometimes lead to better native usage than curated docs, which can anchor the model to suboptimal patterns. And finally, no single framework dominates. The ecosystem is fragmented, and performance varies sharply by benchmark. You need to match the framework to the task. This work ADK Arena is fully open source. It provides a pipeline for automated evaluation and a wealth of data on the agent framework landscape. As the ecosystem continues to grow, methods like LLM-as-a-Developer will be essential for navigating the complexity and ensuring we're building agents on solid, empirically validated foundations. If you found this breakdown useful, check out the link to the paper and the ADK Arena repo in the description. Let me know in the comments which framework you're betting on, and if you think generation cost is the right metric for API quality. Thanks for watching,